So we go down to the bottom here. We have 3 different line segments here, A, B, C, D, and E, F. Very creative names. If I asked you for the length of AB, okay, the distance between here and here, what is it? 6 units. Just count the lines. 1, 2, 3, 4, 5, 6. All right, we're not going to do each one. We're just going to do one. If I go down to here, AB, and ask for the coordinates of A, what are the XY coordinates of this point right there? 2 and 8. That is exactly something like that. And what about the coordinates of B? 8 and 8. 5, 6, 7, 8, and then up. It's 8 and 8. Yep. I know you start counting the lines and they kind of go blurry. All right. So 8 and 8. Now, if I asked you to subtract XB and XA, so what I'm saying is the x coordinate of B. What's the x coordinate of B? 8. Because remember everything's XY, XY. So if I went away, 8 minus the x coordinate of A, which is 2. What does that equal? Which is the same as 6 units at the beginning. So if you want to know the length of a line segment in the horizontal, subtract the x coordinates. Okay? This will come to a formula in a sec. What do you think we're going to do for the y for a vertical? The y values. You're going to subtract the y coordinates. So let's scroll to the next page. Right here. We got vertical lines now. Okay. All right. GH. So we'll do this one. G to H. Can you tell me how long that line is? Well, I would agree with that. Okay. Now, if I asked you to give me the coordinates of G and the coordinates of H. What are the coordinates of G? -3, -8. Close though. What about H? -3 and 4. Okay. And then we're going to do the same thing. We're going to subtract YH minus YG. So the Y value of H, which is 4, minus the Y value of G, which is -8. If you subtract a negative, what are you doing? Right? So this is 4 plus 8, which is 12. Boom. Okay. Now, it technically doesn't matter if you subtract G from H or H from G. Just as an aside, if I went YG minus YH, that's a G. I should do this with my color. I would get YG is -8 minus 4, which gives me -12. Now, you know distance cannot, or length cannot be negative, right? So we just ignore the negative, okay? Which you can do. And you just say the distance is 12. The difference between them It's going to be positive or negative depending on which one you subtract from which. But the actual number doesn't matter, or the sign doesn't matter. We will always take the positive. So I don't care how you subtract them. It even works for the other one. If I was doing XA minus XB, that would be 2 minus 8, which is negative 6. You just ignore the negative, and the length of the line would just be 6. Okay. How do we know if it's a vertical versus a horizontal line? Let's look at that for a sec. Look at the coordinates back on the first page here. These are all horizontal, flat lines. Okay. Look at the y coordinates of AB. What do you notice about them? They are the same. If the y coordinates are the same, it's a horizontal line. I'm not going to test you on this, but it's good to know. Horizontal line. If you look at the vertical lines, what do you notice? The x coordinates would be the same, right? X coordinates same equals vertical. All right. Okay. Yeah. All right, we're going to build upon this. Yes, Hannah. No. Do you want to do IJ? Sorry? Yeah, you just you mean these 2 points? Yeah. Yeah, you just use the coordinates and just subtract them. We can do it quickly if you want. If we look at I, coordinates of I are 1 and 2. Coordinates of J are 1 and 1, 2, 3, 4, 5, 6, 7. We know it's a vertical line because why? X coordinates are the same, so we know it's going to be vertical. So if you just take the difference between the two y coordinates, I'll do it down here, yj minus yi, it's going to be 7 minus 1, which is 6. Or you can go 1 minus 7, which is negative 6, and you just throw out the negative. Okay? Length can never be negative. Okay? We're not done with this. We're going to come back to it in a sec. You know what? Let's go to lesson 2. We're going to couple it with lesson 2, and we'll come back to lesson 1. So we're going to skip to lesson 2, which makes a little more sense to tie into this. Okay. So lesson number 2 is called the distance formula. All right. So the lines that we were looking at before are either vertical or horizontal. The x values or the y values were the same. Most lines are not like that. Most are at some sort of diagonal. So how do you measure the distance of a diagonal? How do I know the distance between here and here? Okay. So what they do, you don't have to write any of this down. Okay. You can just watch me. Is they break it into a horizontal and vertical component. Okay. Now, what shape have I just made? I've made a triangle. And if I'm talking about distances on the sides of a triangle, what formula do we know that can solve that? Sorry? Pythagorean theorem, right? Remember? A, B, C, A squared is equal to B squared minus, or plus, wow. C squared is equal to A squared plus B squared. There we go. And what is C always? The hypotenuse, right? The longest side, the diagonal. So if I know the distance between A and B, which we just did, what is AB? Is it a vertical or a horizontal line? How can it be both? Is side A vertical or horizontal? Horizontal. And when we are looking at horizontal, just bear with me here, on lesson number 1, horizontal lines, I subtracted the x values, right? When we did the vertical lines, I subtracted the y values. So this distance is going to be yb minus y. I'm going to mark it as c because that's what they do there. Again, you don't have to write any of this down. It's coming to a formula that we can just plug stuff into, okay? And this distance here will be the x value. So I'll just say xc minus xa, what they call there, okay? So that's using the formula from the first one. If we plug those into a's and b's, all right, you're going to end up, again, don't write anything down. You'll get c squared is equal to, and a is going to be xc minus xa, it's all squared, plus yb minus ya all squared. And that gives me c squared, but I don't want c squared, I want c, so what do? You square root it. Now, when we square root something, we always get what? 2 answers. Now, does it make sense to have 2 answers in this case? Does it make sense to have a negative distance? No, so in this case, we ignore the negative, okay? So this is called the distance formula, and if you flip the page, you'll see it on the other side. And they're going to use different letters here, but that's okay. So they're going to scroll to, here's the distance formula, written 2 different ways. I prefer this one, okay? D for distance is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared, okay? You don't have to memorize that formula. It will be given to you. You can write it on your cheat sheet, but I will give you, yes, it's in the back of your book. That's the exact cheat sheet or formula sheet I'm going to give you. Yeah, and test, okay? So let's just practice using this a couple times. If they ask for the length, that means distance, okay? As soon as you see the word length or distance or, I don't know, how far 2 points are, you're going to this formula. First thing is to write down what the formula is. So we'll just rehash the formula. Distance is equal to the square root x2 minus x1 all squared, y2 minus y1 all squared. Okay. When they're talking about y2, y1, x2, x1, they're talking about the set of data. So you just have to label one of the sets of data 1 and one of the sets of data 2. So I'll just call P, that's my 1, and Q will be my 2. It doesn't matter if you flip them. And then you just plug in your data. So x2, the x value from data set 2. So what is that number? 10, because remember it's x, y. X, y. Data set 2, x value. So this gives me 10 minus, what's the x value from data set 1? 2. Exactly. It's all squared plus y value from data set 2, -3. Watch your signs. Minus y value from data set 1, 3, all squared. Now you just got to algebra it. What do I do first? Okay, so 10 minus 2. I get 8 squared plus -3 minus 3. -6 all squared. This is why it doesn't matter if you subtract which order you subtract the x's or the y's, because I've got a negative. What happens when you square a negative? It becomes a positive. So you don't have to worry about the negative. It will naturally disappear. So 8 squared is 64. -6 squared is 36. 64, 36. 100. Yeah. Oh, sorry. You have to add them first. Yeah, don't square root them. Add them first. So I get square root of 100, which normally we would get 2 answers, right? But we always want positive because we're dealing with distance. So square root of 100 is 10. So the length of that line is 10. Is that okay? You say no? Yep. It's the last thing you have to do because you're doing. Because each statement has to be a true statement. If you just went from that to this, I know. Okay, in your head you would know. But that if I say that this is equal to this, that is not a true statement. No, but that's what equals means. It means it's a true statement going all the way down. I understand what you're saying. If you forgot it, am I going to take marks off? No. If you go to calculus and you do that, you will lose marks. Okay? Does that make sense? So grade 10, you get more leeway. But don't forget it. Because it's a bad habit to get into and it'll come back to smack you in the head later on. Okay? Do your best. Okay, we'll do one more example. All right, here we go. G and H, we want to find the distance between them. Does it matter what you call set 1 and set 2? No. Okay, what do you want to be set 1 and what do you want to be set 2? Okay, set 1, so that's set 2. All right, what is x2? -17. What is set 1 or x1? -25. It's minus -25. Plus the Charlotte. Oh, why are they not there once I've done this? Because I'm saying the x value from set 2, which is -17, I'm placing that in there. Okay. That's a good question. Okay, what's y2? -5 minus what? 3 all squared. You go from there, and then we'll see. We'll meet at the end, and Charlotte will forget to put her square roots all the way down. that all right? Sorry? Why am I using square? Just because it's not for domain and range, so don't get confused with that, right? It's just I just use them because I had round brackets here, so I just want to use square. But it's not domain and range, so it doesn't mean the same thing. Yeah. Are we okay with that? Did everybody get no? Question 1A and B, please go. 1A, B. So midpoint means the halfway point in the line. So just looking at A and B here, this line segment. Charlotte is on fire today. The midpoint is 5. Midpoint equals 5. All right. There's got to be a formula that we can come up with, though, right? No? Just count it. Just count it out. Exactly. So let's take the x values of A. What's the x value? Or let's do the coordinates of A. Let's just do that. Yes. No, you can just watch. What are the coordinates of A? 1 and 3. What are the coordinates of B? 9 and 3. How do we know it's horizontal other than looking at it? Sorry? There's 2 3s. Y values are the same, right? So you know it's horizontal. Now, midpoint is like average. How do you average something? Divide by 2 in that case. If you're averaging something, you're adding the number of terms together and dividing by the number of terms, right? If I want to average 10 and 20, I add them together and divide by 2. 10 plus 20 is 30. Divide by 2 is 15. 15 is the average of 10 and 20, right? If it was 3 things, you would divide by 3. If it was 4 things, you divide by 4. Okay? Now, take the x values. X, I'll call it xa plus xb. Divide by 2 because it's 2 terms. What's xa? What's xb? What's 9 plus 1? Divide by 2 is? Boom. That's the midpoint formula. What do you think we do for the vertical line? Add the y values. Okay? So if we skip to the next page, going once, going twice, this is all you need to know. Well, you don't even need to know it because the formula is given to you. How does the midpoint formula, people? Okay? Capital M means midpoint. And notice there's one trick to this. It's not even really a trick. They are written as an XY pair. That's why there's a comma there. Okay? Because it's the midpoint of the line. So it has an X coordinate and a Y coordinate. So if I have 2 points, okay, P and Q, and I say, what is the halfway point between them? What is the midpoint between those two things? Again, what we did with distance formula, label each set as set 1 and set 2. Does it matter? No, it does not matter. Okay? So we'll just call P set 1 and Q set 2. All right. So the midpoint. Now, I'm going to say MX. That means midpoint X value. Okay? X value, this is the formula. It's X1 plus X2 divided by 2. What is X1? 4. Plus, what's 4 plus 12? What's 16 over 2? 8. That's the x-coordinate of the midpoint. I'll draw a line. I'll draw this visually out in a sec here. Now we got to do the y one. M of y. The midpoint y value is going to be y1 plus y2 over 2. 7 plus 3 over 2 is... So now we have 8 and 5. So the midpoint, we're not doing B, is 8 and 5. That is the midpoint. So what that means is on a graph, you don't have to draw this graph. This is just a visual. If I have the point 47, there's A, there's P. And then the point 12, 3, 12, 3. There's the line connecting them. The midpoint is at 8 and 5. So at 8 and 5, 8 is there, 5 is there. That's the midpoint. That is the halfway point between the two endpoints. Okay? Does that make sense? So all you do, label each set as set 1, set 2, plug it into the formula, you'll get 2 answers. You write it as an ordered pair. Okay? The only question I want you to do is number 6. Pick 2 of them, please.